Dear students, now we are going to discuss about the principles of random variables and process. So, this random variables and process, why it is required in that antenna design part means, so in any wireless communication systems are inherently random due to noise and multipath propagations and shadowing and interference, and also there is a possibility of multiple signals are there. So by that, there might be that random changes in that amplitude value and the noise level value. So due to that, now we are going to discuss. So using of this random variables and process, we can easily estimate that we can estimate or we can predict. So what are the possibility of occurring of noise level or any delay spread or any angle of arrival estimation parameters? So everything we can known by this random variables and process. So in that, see here, wireless communication systems operate in the environments that are inherently random due to noise, multipath propagation, shadowing, and interference. To analyze and design such systems, these uncertainties are modeled mathematically using random variables and random processes. So this random variable is a numerical quantity whose value depends on the outcome of random experiment. In wireless communication, signal amplitude, phase, noise voltage, delay spread, and angle of arrivals are common examples of random variable. As an example, if one were to conduct measurements of the receiver phase every time the receiver is turned on, the numbers measured would tend to be randomly distributed between 0 and 2 pi. So here the types of random variables. The first thing is discrete random variables. So the discrete random variable takes an finite or countably infinite set of values. So it is characterized by probability mass function which specify the probability of each possible value. And examples of a discrete random variable might be the arrival signal of indoor multipath propagation. So here the discrete random variable is nothing but it might be countably finite set of values. So we should know what are the probability of each possible value. Here we can take the example of discrete random variable is that arrival of signal in indoor multipath propagation, and then we can predict because that is the indoor environment, we can easily predict. And the second thing is continuous random variable can take on any value within a continuous range. So it is described by probability density function. So most physical quantities in wireless systems are modeled as continuous random variable because the wireless medium you might know that, so the variables will be in the continuous, we cannot predict easily. So what that continuous random variables? So here the variable might be the voltage associated with the receiver, noise or phase of the arriving signal. We can take it as. Similarly, the next thing is the random variables are the result of random phenomenon. So it is often best to describe the behavior of random variables using probability density function. So now we are going to estimate the probability density function. So in that probability density function, it provides the complete statistical description of continuous random variable. For example, if you want to analyze one weather prediction model and that particular region, so that what are the statistical average of the rain prediction in that particular area. So that thing only here we list out as that statistical description of the continuous random variable. We are taking the statistical average of that particular range. So now how we can define this PDF means how the probability is distributed over the range of possible values. Every random variable X is characterized by the probability density function. So the probability density function is established after the large number of measurements have been performed, so which determine the likelihood of all possible values of x. So the discrete random variable processes the discrete PDF. So the continuous random variable process continuous PDF. So here also similar of this random variable we have two category, that is discrete PDF, that means discrete probability density function, and the second category is continuous probability density function. So we can define the example also. So see here, this is very important. This PDF, how we can define? See, this is the discrete PDF function. And the next thing is that formula is very, very important here. So see that integral of x1 to x2 p of x into dx. Integral of x1 into x2 p of x into dx. So what is here? This p of x means possible values of x. That x may be any parameter. Possible values of x. Thank you.